So we're going to talk about different types of polar curves. Rose curve, so the form r equals a cosine n theta, and r equals a sine n theta, where a is not equal to 0, and have graphs that are rose shaped. If n is not equal to 0, is even, then the rose has 2n petals. Okay. If n is not equal to plus or minus 1, is odd, then the rose has n petals, right? So an example is r equals 2 cosine 2 theta would be an example here. Now n here is even, and so it has 2n petals, so that's 2 times 2, that's 4 petals. So that tells me it has 4 petals. All right, the graph actually looks like this. Okay. Starts here, loops through. Oh, didn't do my looping right. So it kind of looks like that, okay? 4 petals there for a rose petal. Now, the Lemniscates, this is r squared equals a squared sine 2 theta, and r squared equals a squared cosine 2 theta, where a is not equal to 0, and have graphs of proper propeller shaped. Okay, propeller shaped. Okay, so you've got an equation like r squared equals 4 sine 2 theta. And so what does this look like? Comes out, and it comes in, comes out, and it goes in just like this. Okay, so it's kind of a propeller type shape going on here. Now, with the app that I have, I can't graph this, but what I can do is I can try to set up my camera, see what happens. I've never done this, so we'll see if it continues to record. Okay, and let's try to graph. So what I want to do, oh goodness, this is not good. All right, so maybe I'll try it like this. Okay, so I go to mode and I go down, and right now it says function, but you're going to move over to polar, and you're going to click the polar, and you're going to quit, and then you're going to go in, and now you can graph. Okay, and to graph that rose, the rose equation, so that was 2 cosine of 2 theta, close parentheses. I hit enter, and now I'm going to go to graph, and you can see how it graphs. Now it's kind of hard to tell, so maybe I can zoom in a little bit, and it looks better now. Okay, so that's what's going on there. Maybe that's cool, maybe it's not, whatever. Okay, so let me clear that out, and let's not graph the rose, but the Lemniscates, and let's see here. It was r squared. Ooh, how are we going to do r squared? Maybe I have to take the square root of it, because that's just r. So let's try that. I hadn't done this, so we'll see. Square root of 4 sine, this might be a total mess. We'll see what happens. 4 sine 2 theta. Close it. And then graph it. All right. So that's the Lemniscates right there. Okay. So it doesn't look beautiful, but you know, close enough. Gets you an idea of kind of what these shapes look like. Now, graphing a spiral, so like a spiral equation, maybe you have an r equal to e to the theta divided by 5. So what does that look like? It spirals out. So what I'm going to do is I'm going to hit zoom, and I'm going to zoom out. And you can see how that spirals outward. And it keeps going. It just stopped there. But it doesn't technically stop. Okay. So that last one, we graphed r equals e to the theta over 5. So your polar, let me back out, your polar axis here. So you start at 1, because theta is 0, that gets me, so theta equal to 0 gets me an r equal to 1. And as I increase theta, the curve gets further and further away. And it just keeps spiraling outward. Okay? If you do negative, it's going to, so the negative theta, so theta less than 0, it's actually going to pull it inward to like a little black hole. Okay? So that's the graph. Okay? I don't know why I put graphed. Okay, so that's the graph of that one right there. All right, so just, make sure you got it. You go to mode in your TI-84 calculator, hit the mode button, and then go down to the func par pole and then sequence, and select the polar form, and then go to your y equal button, and you should see the \r1 equals, and then you put in whatever you want. Okay? All right. So that pretty much covers the different polar equations you've got going on here. Really the biggest key here is just plugging in points for theta and then plotting those points correctly. Okay, so that's really all there is to this section here. Taking your table of fixed theta values and plugging it into your equation, and then plot the points. Okay.